Can you hear me correctly? Yeah? Okay. Did you have a good break?
Yes.
Yeah? Thanks a lot for staying with us. Okay, so as said by Tuli, we are going to talk on how to boost your EDA productivity with AsyncAPI and Microcks, because this is one of my favorite topics, because I have to confess, I'm a lazy developer. And most of all, I hate bad surprise when they come very late in the project. So I wanted to share my tips and tricks to avoid a waste of time, to avoid the frustration regarding development in EDA, in event-driven architecture. And this is just by leveraging AsyncAPI artifacts and using a tool, an open source tool I'm working on, that is Microcks. So we will go through a quick introduction, then a live demonstration, and I hope that by the end of the talk, you will have understand the benefits of this approach, and you have learned something and see how it can be used to also have a better communication between your development teams within your projects. Okay, so before diving in, a few words on me. So basically, I'm an open source fanboy. I am one of the co-founders of Microcks, and until very recently, I used to be a cloud native architect. I was working in insurance companies and then at vendors. I've been at Red Hat and Google. And yeah, since the beginning of the year, I have the opportunity to work full-time on Microcks. That was previously my side project. So I have strong background in API programs, in design of distributed systems, and also on the underlying infrastructure, whether based on Kubernetes or cloud provider services. And on a personal note, I'm spending a lot of time with my kids. I'm also a gardener and a pastry lover, so you will see why later on. So it has been done before by every speaker, but you hear my introduction on why we need event-driven API, why messages are important, and what could be the pitfalls, the issues when you're trying to adopt event-driven architecture. So obviously, you all know that we are living in an interconnected world, so a lot of devices, of laptops, of data centers everywhere, but this is pure distributed architecture, okay? And API are paramount to allow us to release those different components independently in isolation, and to have, yes, full speed regarding the release cycles of those components. But one thing on this schema is that arrows here are not just arrows. They represent networks. And with networks come latency, comes security boundaries, and comes failures. So if you just stick with synchronous request response style REST APIs, for example, you finally met all those failures, and you will see that you are not able to scale to more complex, more highly available distributed architecture. So that's why we absolutely need to introduce asynchronous communication, message-driven architecture to have all these benefits, adding resilience by being able to replay messages, adding scalability with non-blocking request response style of communication, and also adding elasticity, because the more you get events in your system, the more you can add consumers so that you keep a consistent quality of services regarding the time you take to process events. But so messaging is really great for runtime decoupling, but introducing messaging by itself is not enough to really achieve this runtime decoupling, because most of the time when you come to this kind of architecture, you start touching a microservice somewhere and it breaks everything. So finally, you may end up releasing everything together and come to that situation when all the components are released together, they are validated together, and you have the same version everywhere. This is a distributed monolith. So we absolutely want to achieve this. We want this kind of versioning scheme where all the components are released, validated, developed independently, and we need a high level of confidence to do that. So we need to change our way of doing. We need to integrate new techniques like simulation, contract testing, and so on. So with the rise of EDA, there comes a lot of new challenge. We talked about this previously, but we have a lot of use case to cover, from the more, let's say, tactical one that is enhancing the user experience through WebSockets, for example, to the more strategical one that is embracing a cloud-native architecture with being able to handle region failures, for example, with everything in between regarding microservices or process, orchestration, choreography, and so on. So we have a lot of use case to cover with a lot of different protocols that may be well suited for some use case, but not for some others. So a lot of complexity. The technical environment as well can be very complex, especially for developers. They know how to set up an HTTP server, but most of the time they don't care about setting up all these different brokers. It can be tedious for them. So as a consequence, we really want to avoid introducing a new build-time coupling. You know that messaging allows us to have decoupling at the runtime level, but if you had too much complexity to the developers, to the project team, to the testers, you introduce a build-time coupling, and that's really bad. So the point is really to try to work efficiently as a team, and obviously AsyncAPI is a part of the solution because it gives us a shared understanding, a common knowledge of the capabilities of APIs. It allows a better communication in the project, but we also need to have efficient tooling to propose a pragmatic approach to developers. And that's exactly where Microcks enter the games. So Microcks is a cloud-native tool purely dedicated to API mocking and testing. So it's a pure open source project. We just entered the Cloud Native Computing Foundation this summer. We are a sandbox project now. And one really unique thing about Microcks you have to understand is that our goal is to provide a uniform, consistent approach, whatever the kind of APIs, because we are really aware that those different kinds of API must coexist for a long time in complex enterprise systems. So with Microcks, you can obviously simulate, mock, and test REST APIs, but also GraphQL, gRPC APIs, asynchronous APIs, and even your legacy SOAP web services as well. Okay, so really a tool, you'll see that in action, so to handle all the different kinds of API. And to handle this kind of API, we are doing this by leveraging the existing artifacts. The goal with Microcks is not to introduce a new specification format, a new file, a new artifact. What we want to achieve is being able to reuse all your different artifacts directly, without any transformation, without any translation, and without writing code. Just integrating everything, these assets, or even your live traffic recording, for example, and being able to build upon this, not having you to create new artifacts specifically for Microcks. So just, yes, full disclosure, I'm working for Postman. I'm a Postman employee, and I'm part, in fact, of a department called Open Technologies, and this is where Postman is investing in open source communities, open standards like AsyncAPI, like JSON schema, like GraphQL communities as well. And so with Yassine, we joined the Postman at the beginning of the year. And the goal was to put Microcks under a neutral umbrella, the CNCF, and having still Postman, let's say, as a sponsor to the project. But the project still and will remain 100% driven by the community and open source. So now let's get into the details. How does Microcks work? So we all know the importance of contract, of specifications, but also at Microcks, we do think that examples are really, really, really important aside your contract, your schema, your specifications. And when we talk about examples, we are not talking about randomly generated examples being with all the string being lorem ipsum, for example. We do think that examples are the best way to convey the real intent of your API, to make consumers sure they really understand the business expectations, the behavior of your API, and where they are carefully chosen, these examples can be transformed into executable specifications, executable datasets, and that's what we are using to provide mock and also to generate test suites for later on checking the conformance of your API implementation. So luckily, in AsyncAPI, we have the examples. I was one of the contributors who introduced the examples of AsyncAPI specs, and that's a kind of artifact we can directly leverage into Microcks, plus some other more artifacts we'll see later on the demonstration. So we talked about the unique thing about Microcks being consistent over different API style, but when it comes to asynchronous protocols, we also have a very uniform approach, and whether you are dealing with microservices orchestration with Kafka, dealing with dynamic UX using WebSocket, or lightweight or IoT connection using MQTT, cloud native messaging with AWS or Google PubSub, you have all these kind of bindings protocols already available in Microcks. And it's really easy to extend and to add your own contribution if your protocol is not yet in the list. So really easy. We had several contributions for the community on SQS, on NATS also, on PubSub. So really easy to add your own connectors if it's not yet in the list. So now that we got contracts, examples, and protocol bindings, we can go to the next step. Fake it until you make it. And this is a really important concept because this is where you will shorten your feedback loops. This is where you will allow your development teams to work in parallels, where you give them the tools to be able to replicate a bug, to test really quickly and in isolation a new fix. So it's really important having this concept of mocking, of sandbox, so that developers can work very, very efficiently. And so when it comes to AsyncAPI, we have usually this kind of question about, in the community, about what is really the semantics of mockings and what it allows you to do. And we provide this little schema here because in the situation of AsyncAPI, we have two cases to handle: the subscribe and the publish operation. So typically, when you subscribe, mocking allows consumers to get the events before your provider is actually ready. And testing allows you to check that your provider handles correctly its promise. That means the messages it produces are actually confirmed. And in the second case, which is a bit different, mocking allows the provider app to consume events without having to have consumers sending events. And testing allows to validate and maybe to find the consumer that is actually sending garbage to the owner of the API. So it's really important to have this in mind and to refer this. So what could be the benefits of mocking and testing for the different situations? So what's best than a real-life demo? And we are going to talk about pastries, of course. So we are going to have these very simple events on the left. So we want to manage events for ordering pastries. So an order has a unique ID, a customer ID as a status, and a list of product and quantities. And we are going to expose these AsyncAPI API events using two different bindings. So because we have two different use cases to handle, we want to have a very dynamic UX in an administration console, for example, where you are tracking the business activity. So we are going to use the WebSocket binding. And we want also to propagate these events to some external systems like CMS, whatever. And for this use case, we will use AWS SQS. So this will be the context of my demo. Okay. So I'm going to start with the AsyncAPI specification. Is it big enough? Yeah? Yeah? Okay, so it's a very simple pass-tree orders API. Okay, you can see that I have the schema that is giving details on the pass-tree order, so the different required properties, okay, that are described below, and so on. And so to start, we are just having one binding here, that is the WebSocket binding. Pretty easy. Okay, and then we're going to switch to Microcks. So as you can see, Microcks can act as a central repository for your API's definition. So here we have loaded 3 different kinds of APIs. So we've got the REST, the GraphQL, and gRPC1. Okay, we can see them here. And what we are going to do is we are going to import this new AsyncAPI definition. We can also connect to Git repository so that it is always in sync with the Git repository, discovers different versions and so on. But here, for convenience, we are just going to upload. So pick up my file. Okay, this is my pass-through orders AsyncAPI. Upload it. And I get a new event-based API definition right here. So everything has been discovered. I've got the AsyncAPI spec. I can view the documentation as well. And I can see the mock in the operation, but wait a minute, no mocks here. Yes, because as said you before, I'm very lazy. So I don't even want to type the example because I want to use the new feature we have in Microcks that is using generative AI to allow you to generate samples for us. So I not necessarily recommend this as the best practice, but it can be really handy if you want to generate samples really, really quickly. So we can review the samples. So here, for example, it's we have to rename it. It's a created order with a croissant and an eclair. And here it is a validated order. Yeah, I got one in the past. Okay. And so I'm happy with this, so I can just add. And I've got 2 nouveau samples here. So Microcks is able also to source and to find samples in different sources. So it could be directly in the AsyncAPI, it could be in your live traffic record, it could be with the help of AI, and it enrich its data sets of samples that way. And so I have to just have a little manipulation right here. It will disappear in the next version, but I have to first disable and enable it once again. So once I have produced samples, Microcks has generated for me a WebSocket endpoint. So as a developer, I can get this endpoint right here, use a simple WebSocket client, and then connect to this endpoint. You can see that I should receive, yes, new orders each and every 3 seconds, because for now, it's the default frequency that was configured. So I didn't write anything, not a single line of code, just using my raw AsyncAPI definition, and I can have my front-end developers that start working from scratch. Okay? So really, really handy. So second step, I want to evolve this API, and now I want also to send this event to an SQS queue. So let's check my AWS console. So you can see here on my SQS console, I just have 4 queues. Okay, they are pre-existing. And what I'm going to do is I'm going to change my AsyncAPI definition, and just I'm going to copy-paste here the new bindings I need. I need the SQS one, so copy and paste here, just save, and I can import it again in Microcks. Just upload once again the same file. Checking the time. Here, okay. Upload, that's okay. And if everything is okay, we now have a new binding here that has been discovered. And because Microcks is already configured to your AWS instance or your local stack instance, if you're using local stack for laptop development, it has connected to this and it has created its own queue. The administration of this queue is managing this queue, and you can see that on this queue, just refresh it. Here on this queue, I can see that these are, yes, I already have 27 messages, and you can see that Microcks is also sending mock messages on this protocol. So you can add as many protocols as you want. We are discovering everything that is in your AsyncAPI specification, and as long as you are connected to different brokers, different environments already existing, you can have mocks for free, messages for free, very, very rapidly. So these are static messages, but we have also features in Microcks that allows you to craft those messages that have been generated by AI and replace some parts to say, for example, here I want a randomly generated UID. Here I want a randomly generated email, so that you may have variations into your mocks. So it's really handy also to simulate real-life traffics and so on. Okay, and the final part right now, because for the moment we just talk about the mocking part, but you can see that we have these testing things right here. So here what I'm going to do is I'm going to check, I should have this queue, past 3 orders, that is another queue. Let's say it is the queue that is used by my real application that is deployed on my QA environment, whatever. And I'm going to prepare the sending of message. So just taking a fake message right here. Let's imagine I have an application running that is doing this, but yes, I'm doing this by hand. And what I want to check is if Microcks is able to check the conformance of those messages on the SQS queue. So I want to run a new test. I have to specify my test endpoint. So I want to, yes, to test a SQS binding. So this is the syntax for SQS binding. And here it's really, indeed, it's just the region and the name of the queue. The operation I want to test is the subscription for orders. And I want to validate the messages regarding the AsyncAPI schema. As an advanced option, I have to specify the credentials, the secret used to connecting to my environment. So it could be the QA environment. It could be also the production environment. We have users in the community that are using Microcks in production to just check the messages after a new deployment on the production environment as well. So really handy for that. And so I'm going to launch the test right here. And quickly send message, send another message. 2 should be enough. And the default is 10 seconds. He is waiting for 10 seconds. And yes, should be OK. We have found 2 messages, and you have access to the full results. So you can see everything is green right here. So you have no drift regarding the schema. If we try to change things a bit, let's say I'm going to purge the message just to clean up everything and prepare a new message. And just, for example, removing the status that is required. Getting back to Microcks, I can relaunch this test. OK, launch test. Quickly send message, 1, 2. Just wait for the test to end. Yes, it's a failure here again. Why? Because the object has a missing required property, so we expected a status and no status in the message. So really handy to check that what you send actually is compliant or not. So here I've done everything manually. It's nice to discover the tool, but in real-life use case, we will put that into your CI/CD pipeline. So whatever you are using, you can, we support different CI/CD pipelines technologies. So for example, if you are using GitHub, we provide you the code, you just copy-paste this into your GitHub Actions, and each and every time you will deploy a new revision of your component, you will be able to ask Microcks to perform this type of conformance test to check everything is okay. And obviously, you can do this on the latest version, but also on the previous one, so that when you deploy your version 1.2 that is expected to be backward compatible, you can also check that it is still conformant to the 1.1, 1.0, and so on and so on. Okay, so really handy to put this in your CI/CD pipeline. Okay, so as you've seen here, we've used Microcks, let's say, very manually using the graphical user interface. There is also another way of using Microcks. You can embed it directly into your code, into your unit test, because we provide bindings with different languages through test containers. So you can run Microcks, as I've done here, in your Kubernetes cluster, in your whatever, as a central instance that is always up and running, that can be used as a source of truth for all your teams, for example. But you can also very easily pop out ephemeral instances, Microcks from your JUnit test, for your Jest test, for your Go test, whatever. And so you can have all these checks done on your laptops before actually committing your code and triggering the CI/CD pipelines. Okay, so as a wrap-up, I want you to have this in mind. So with Microcks, you can handle a multiplicity of protocols with great flexibility regarding the deployment, regarding the triggering, regarding the integration with your CI/CD pipeline. So think about how you are going to evolve regarding your EDA maturity and the different use case you will have to handle. So we think we have a great tool that provides a uniform and consistent approach, whatever the use case. You have seen that Microcks, the mocking part is really instrumental to ease and to spread your EDA adoption. So in REST API, we talk about the time to the first call, and we have to take care about the exact same things for AsyncAPI as well. So when a developer has an AsyncAPI spec, he should be able to connect to something very quickly, and Microcks can be here to provide a sandbox as a service through mocking. And you see that conformance testing is really key so that you can secure your delivery, integrating everything into your pipeline really, really easily. And I think that's it for today. Thanks a lot, and thanks for your questions. Any questions?
Do we have any questions? Questions. Is everyone okay? You are all looking. Are you sure? Are you tired? Okay, we have a question.
Great presentation, first of all.
Thank you.
I was just curious about the conformance verification of your schema.
Yeah.
I'm just curious, do you only validate the schema that's on the SQS, or would you go about figuring out whether the application itself behaves or breaks differently? If you, like, I'm just trying to figure out whether, okay.
You have in mind what you have shown this morning regarding to test some of the queues and this kind of stuff?
Yeah, like what I'm asking is, you had a conformance score somewhere in your UI. You just said, it went from red to green. That conformance score I was not able to see in the schema. Is that associated with the schema, or am I mistaken?
Yeah, here it is associated with the schema because we used a test runner that was AsyncAPI schema validation.
I see.
But we have the ability to have different runners that will allow you to apply different testing strategies. For example, you are also able to, we have a Postman strategy that will allow you to reuse your business logic that is integrated into your Postman collection as a test script, for example, to check something else. So here is just schema compliance, schemas compliance, but you can integrate some of the testing strategies as well.
Got it. Thanks for the clarification.
Do we have any other questions? Thank you so much, Laurent.
Thank you.